Our story begins over 4.5 billion years ago. Imagine a vast swirling cloud of dust and gas. This is the Milky Way galaxy, our cosmic home. It's a chaotic place filled with the remnants of dead stars and the seeds of new ones. Gravity is the maestro of this cosmic orchestra, pulling everything together in a grand swirling waltz. Within this swirling mass, a particular cloud of gas and dust begins to collapse. This cloud, much larger than our solar system, is filled with hydrogen, helium, and traces of other elements. These elements were forged in the hearts of long-dead stars, their fiery deaths seeding the universe with the building blocks of planets and life. As this cloud collapses, it begins to spin faster and faster, like a figure skater pulling in their arms. The center of the cloud heats up, a cosmic ember about to ignite. This is the beginning of our solar system, a tiny pocket of order in the vastness of space. The heart of the collapsing cloud continues to heat up under immense pressure. Temperatures reach millions of degrees. Hydrogen atoms, forced together under unimaginable pressure, begin to fuse. This is nuclear fusion, the engine that powers the stars. With a burst of energy, a star is born, our sun. It blazes with light and heat, illuminating the surrounding disk of dust and gas. The sun's powerful gravity begins to shape its surroundings, pulling in more material and influencing the destiny of everything around it. The birth of the sun marks a turning point in our story. It provides the energy, light, and gravitational pull that will shape the destiny of our planet. Without the sun, there would be no Earth, no life, no us. The space around the newborn sun is a chaotic construction site. Dust grains, remnants of the original cloud, swirl and collide. These tiny particles, drawn together by electrostatic forces, begin to stick together. Over millions of years, these clumps grow larger, forming pebble-sized objects, then boulder-sized, and eventually kilometer-wide planetesimals. These planetesimals, drawn by the sun's gravity, orbit in a vast disk. It's a cosmic dance of collisions and mergers. Some planetesimals are flung out of the solar system, others collide and shatter. But some, through chance encounters and gravitational attraction, continue to grow. This process of accretion, the gradual accumulation of matter, is fundamental to the formation of planets. Over millions of years, the solar system transforms from a chaotic cloud of dust to a more ordered system of protoplanets, still evolving but taking shape. Section 4. A molten Earth, the early years. One of these growing protoplanets would eventually become our home Earth. In the early solar system, Earth was a very different place than it is today. Bombarded by asteroids and comets, its surface was a molten sea of magma. The heat from constant impacts, combined with the decay of radioactive elements within its core, kept Earth in a molten state for millions of years. This early Earth was a hostile and unforgiving environment. Volcanoes erupted, spewing lava and gases into the primordial atmosphere. The surface was constantly reshaped by impacts, a testament to the violence of the early solar system. But beneath this chaotic surface, a more familiar Earth was beginning to take shape. Section 5. A layered planet, Earth takes shape. As Earth cooled, a process known as differentiation began. Denser materials like iron and nickel sank towards the center, forming the planet's core. Lighter materials like silicates rose to the surface, forming the Earth's crust. This separation of materials is crucial to Earth's evolution. The molten iron core generates a magnetic field, which acts as a shield, protecting us from harmful solar radiation. The solid crust provides a stable platform for the continents and oceans to form. Over time, Earth continued to cool, and the molten surface solidified. This marked a significant milestone in Earth's evolution, setting the stage for the next chapter in its story, the emergence of oceans and the first signs of life.